Okay, so these are notes day 4. Like I said, I'm going to re-record day 3 stuff with the summation symbol. That summation symbol like this. But I'm going to keep going. We got to keep going because I'm going to assign some homework tonight from WebAssign and you'll be able to understand all this. Okay, here we go. Huge day, for sure. If you were given that the derivative is 3x squared, and I told you what is f of x, and asked what f of x would be, what would you say?
6 or x cubed or x to the 6th.
Okay, so there's x cubed or x to the 6th. It's x cubed. And the biggest reason that we know this, there's about a lot of points that I'm about to tell you right now. There's some that are 2, some that are 300. Yeah.
No, you need to add a plus c because you can add any constant.
Okay, so he's way ahead of the ball game. Yes, you need a plus c for sure. We're going to talk about that here in just a bit. He's just way ahead of us right now, and that's why I just gave him 200 points. With this being said, f of x is called the antiderivative. Anti usually means like against, right? Opposite. This isn't like a negative opposite. This means a backward process. Imagine yourself as a baby, right? When you first came to my class as a baby, you first had to learn how to stand. That was like review of pre-cal. Then you learned how to walk with like rules of differentiation, right? And then you're learning how to walk faster or whatever. And finally, you're going to learn how to walk backwards. You're going to moonwalk for a while. Okay? No, I can't moonwalk in these shoes. But anyway, so you're going to moonwalk, and then we're going to start running backwards. The second semester is always a backward process. It's the antiderivative. Okay? So this symbol right here, whoops, it means the integral, the way we read it, of g of x, what else? In respect to x. This in respect to x business is right here with this dx, just like what we used to do with derivatives as dy dx. That means in respect to. Our function that we were given back in the day when we were doing easy derivatives, it had to be blank, blank of x for us to be able to derive in respect to x. It had to be written in terms of x for you to be able to derive it. Do you understand? Otherwise, you couldn't derive it. So with that being said, this right here has to be written in terms of x so that you can integrate it. Oops, the term integral is a synonym for antiderivative. Okay? So what would the antiderivative of g of x be? Ooh, that's good. Capital G of x. Rovik's going to try to get those points again unless someone else has something.
Plus c.
Plus c, right? So plus c is what we're going to do because it's the antiderivative. These are called indefinite integrals. Definite to you might mean, okay, it's a definite answer, right? Or it's a definite value. This is all indefinite means. If I told you to find me a definite integral, I'm saying one that has a definite boundary. That's a definite integral. And one person in second period got 300 points because of the question this person asked. And I'm going to see if I can lead you to that same thing. Okay? This is a definite integral. An indefinite integral, what is that looking for?
Take the integral of something that doesn't
of something that doesn't have boundaries. I'm just going backwards. You'll learn it here in just a bit. Power rule, remember what power rule was? We're about to learn the reverse power rule. Okay? And the reverse power rule will get you back to that antiderivative. A definite integral has definite, pun intended, bounds. Where an indefinite integral, it doesn't have bounds. You with me? There's no bounds from A to B. Let's see if that helps lead it to you. What?
It's not area bounded.
It's not area bounded. An indefinite integral is not area bounded. A definite integral is, but an indefinite integral is not.
Doesn't it just give you like a general function?
This will give you a general function, okay? The general function that it gives you is this something plus c that Robic was talking about. No one has mentioned the 300 points yet. So this right here is involving c, and the other one isn't. What have we done in the past that looks and feels like this, what we're doing now? Not mx plus b, that's a good, in some respect, yes, but not where I'm leading right now, okay?
It's like the c is like constant.
C is a constant, but that's not what I was going for.
So I was thinking like the definition of the derivative, there's the alternative and there's like
Woo! Ding, 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 winner, winner, chicken dinner, 300 points. So right here, this is big. So this will go back to some form of f of x plus c. This gives you some kind of function plus a constant. Where this one just gives you what?
The exact point.
Not a point,
Exact area.
but an area, a numeric answer, like a number. Does a number answer have a variable x in it? Nope. It's a number. But this is an equation. Remember when we did the definition of the derivative and h was approaching 0 of f of x plus h minus f of x all over h as h is approaching 0? And all of this gave us f prime of x is equal to some in terms of x function? That's what this is related to. And he even said it by name. I might even give him some more points. I don't know. So let's see if you can get some points from here. What is the alternate or the alternative equation for the limit? Say it.
so the limit of as x approaches a
Of x approaches
c.
c. Don't look back. Don't look back. As x approaches c of what?
Of f of x minus f of c divided by x minus c.
Perfect. So right there, this is the alternative form because he helped you. This is the alternative form. And this, what does it give you?
The definite.
No, it gives you f prime at a specific c. It'll only give you one slope. So if you want to find another one, do all that all over again. Remember that? How annoying that used to be? And we preferred the integral function, or sorry, we preferred the in terms of x one. That's how they're correlated. Cool? Be honest. Raise your hand if you fully understood what just happened. Okay, that's good. Let's go to, maybe? Okay, so now let's going to go to, we're reversing differential rules. You tell me, does a relation exist between those two things?
No. Well, that's the inverse.
Okay, it's an inverse. What's happening there? Is it quote unquote walking backwards?
No.
It actually is. Is there a walking forward and walking backwards that happened there?
Yes.
Yeah. Are they the same?
No.
Tell me why they're different. And
Because
here are
that's-
points. Which one?
Okay, so f of x to f prime of x, or not, sorry, I'm doing the first one.
Okay, you're doing the inverse.
Of x.
Okay.
That's, the input for that one is gonna be the output for the other, or like, the
Yeah.
inverse.
The input for the f of x will be the output for the inverse.
Yeah.
Keep going. What else?
About
And
that
that's not the same thing here.
No, because.
You're right. Look at that. Someone did not say that second period. The input of that one is the output of the other. That does not happen over here. There's other differences.
You can take as many steps as you want on the derivative.
You could take as many. You could take as many derivatives as you want until it all zeroes out per se, maybe. Where here you're not doing that. He's exactly right. Alec, what's next?
For the inverse, the original function is reflected across y equals x.
Perfect. The inverse is reflected across y equals x. This one, there's no reflection. For the 300 point difference that I want people to say, is there anyone else that wants to say something?
Do you want us to use like integrand and antiderivative to explain?
I want you
those?
to use whatever you want. I want to see if you're there.
Probably not.
It's okay if you're not. You still get 100 points.
On the second one, they have the same x inputs, but the x output is determined by the slope of the previous derivative.
I see what you're saying, but that's not what I'm looking for. And that kind of was a little bit taken from the interpretation of the inverse, okay? But you're exactly right. That's not the one I was looking for, though. Alec, what's up?
I don't know if this is right, but for the inverse to go from the regular function to the inverse, then from the inverse back to the original function, you do the same thing. But to go from the original function to the derivative, and then back to taking like the
I know what you're doing. Keep going.
to go back, you do the opposite thing.
Okay. He's the closest right now. I'm going to finish what he said. He's the closest. It's just the words he's using are a little bit off. This right here deals with operations. Addition, subtraction, multiplication, division. I can square something or square root it. I can divide or multiply. You see what we're doing right now? Where this one, it doesn't do that. This one is a backward reverse process of these things. It's not the reversal of operations, it's the reversal of derivative rules. Okay? And here we go. You're about to learn, please memorize these as fast as you can, hopefully by next class. Okay? This right here is the reverse power rule. What we used to do is we used to bring that in right in front and take away from the power. We multiplied and then we did n minus 1. This is the opposite now, the backwards, the antiderivative. We're going to add 1 to the power and then divide, not multiply, but divide by the new power. And he was way ahead of us. Rovik is right. Then we're going to add this constant. Now look. Why does it say that n cannot be negative 1? I can't divide by 0, right? This right here is called my answer, aka my integral, aka my antiderivative, aka my f of x plus c. Right? My f of x is equal to something plus c. My function plus c. Now, if this is the antiderivative, what could we do to this answer to get back to the original integrand?
Do subtract 2 from
Derive it. Just say it out loud. Don't raise your hand. All I have to do is derive it. If I got the antiderivative, gave me the stuff in blue, that means I could derive what I did back in first semester, the blue stuff, and I should be able to get this gray stuff. What happens to the C?
Take a constant, so
It
it's
becomes
0.
0. There's about 5 to 10 C's that you might have to worry about on a test. And if you forget to write them all, you just got a 90 or an 85. So please do not forget to write the C's. Also, please, what happened to the summation symbol in the dx when you integrated?
Can you say that again?
What happened to the summation symbol? This symbol right here, guys, this squiggly, is the same as that stuff.
I mean, when you're dividing something that has, like when we were doing implicit differentiation, it was like saying this thing times dx over dx,
Mhm.
and that canceled out to a form of 1. So is that what that's doing there?
Okay, that's a good observation, but it's not canceling to a form of 1. That's not what's going on here.
Well, we're dealing with infinitesimals, so it's like represented by the times dx.
Yeah, so we're doing infinite number of rectangles. And when this process happens, it's like a magic trick. This integral sign, the summation sign right here, the squiggly s, summation sign, and the in respect to, they disappear. Because the process of what Robic just described just happened. You see what I'm saying? So that's why this, what's in blue, is left over after that process. If you forget to write a dx, guys, your work is about to get really lengthy. Okay? Each time you forget to write a dx, it will be minus 1 point. Okay, your attempt points are gone, so please make sure you're understanding it right now. I hope I can communicate how very, very meticulous your work has to be. Okay, here we go. What's the derivative of sine? Cosine. What's the derivative of cosine? Negative sine, right? I have it right here. The derivative of tangent? Secant squared. What's the antiderivative of secant squared? Tangent.
Plus C.
Plus c.
Yeah.
Yes. So look what happened here. I have a sine. That's not the same. You see what I'm doing? I could look at this negative and kind of pull it out and ask myself, what's the integral of sine of u? What's the integral of sine? Cosine.
But if you put the negative
And then I can put this negative back in.
plus C.
Wait, no one corrected that. I said, what was the integral of sine?
Negative cosine.
Negative cosine, but he said cosine
No,
before.
I meant cosine is in the summation thing, then you add the negative back in.
No,
because
it's
you take it
negative
out.
cosine, and then the negative outside makes it back to positive cosine.
So what just happened? I'm trying to, okay, listen. What's the answer to this right here?
Cosine plus c.
Cosine. Positive cosine plus c.
Do you not leave
Positive cosine plus c is what that one is. But see, I'm trying to confuse you right now. I'm trying you to keep track of your negatives. What I should have done was integrated cosine. Pulling out this negative, what's the integral of cosine of u? Sine. And then multiply this negative. That's how we get this negative sign, like interpretation from like over here and stuff. Are we good? Do you see what's going on here?
So when you integrate, like, the opposite of the integrate,
So,
integrand, that's the word.
no worries. This is the integrand. And this is the antiderivative, or the integral. Remember what I just did just now? And I said it comes all the way over here? What would I do to this again
The opposite,
to get it here?
to the opposite integral of
Just derive it. I just derived it.
That's what that is.
Yeah, I just want to make sure you're understanding what levels give what, okay? So the derivative of the answer should give me back to the integrand.
So the derivative of negative cosine is sine.
Because the derivative of this would be like positive sign. Okay, so there's the O, okay? That's what I was trying to show you guys. It's easy to get confused as I just did that to you, but I want you to keep track of what's going where. Okay, And the same thing, guys, will happen with the negative here at negative cotangent and negative cosecant of how it relates to those negatives. Alright, here we go. Deriving your answer can get you back to the integrand. The integral of the sum is equal to the sum of these integrals. Same. Integral of the difference equals the difference of the integrals. This is another 300 point coming up. This is what? Constant multiple rule. That's not the 300, but that's constant multiple rule. This is saying no. There's no such thing as a reverse product rule. You cannot rewrite this to be that. Was there, let me ask you from before. Remember when I told you that if you have f of x times g of x, it's not the derivative times the derivative?
Yeah.
You had to do what?
Use substitution.
Okay, no, that's not where I'm going. I'm saying here, you're right for the integral, but we're talking about derivatives.
F of x times by g prime of x.
You have to do first times the derivative of the second plus the second times the derivative of the first. Okay? Because of that, the same thing with antiderivatives. We're going to have to use substitution, which you will learn next class. Because that's a big thing right there that she just mentioned. But we're not going to learn that today, okay? Why is it that I can split this up here, but I can't split it up here? Besides the obvious that I said there's no such thing as a reverse product rule. What's so special the way it's written up here versus the way it's written here? Say it. Don't be afraid.
Is it the in respect to x?
They're both in respect to x. It's not that. It's subtle, but big. It tells you. Huh? Not parentheses.
Because in the first one, you're talking about accumulation of like some change, so you're getting the area. So it doesn't really matter if you like distribute integration.
So, did you distribute these integral signs?
I mean, you didn't distribute. I mean, it's an integration law.
Yeah, you applied it to both of them, right? You're almost there.
Is it because of like the properties of like multiplication versus addition? So like if you do that first one, the reason you can add them is because if you have like a rectangle, so you have like
Keep going.
dx, and then the f of x and the g of x would be like the height of the rectangle. And if you were like to add the two heights of the two rectangles together, then multiply by the x.
He's close, okay?
It would work.
He's not saying in the ways that I'm wanting, but I'll give him half points.
You always gotta speak up.
And because
Those are
Robert
points.
started it off, I'll give him 50 points. Look, the biggest thing is this. How many terms do you see up here? Two.
Oh, and that's one term. Oh.
And this is one term. You have to say it that way. So, one term goes to use substitution. What Chloe was talking about. Two terms, easy integration, reverse power rule. I'm trying to help you guys see all these shortcuts so that you don't have to do 30 to 50 problems to understand what I'm talking about right now. Okay? Here we go. This is why I stressed one term versus many terms. How many terms are in this example right here? 3. This one? 1. 1. 1. 1. 1. 3. So 3, right? I don't know why, but these are the exact same thing. But we'll just do it one time. Oh, check this out. How many terms do you see? One. We see one term right there. And the reason why we see one term is because those two binomials are glued together by what? Multiplication. What's easier right now to do? One term or more terms? More terms. So how should we rewrite this? Distribute. Do you understand? All these things we're trying to piece in compare and contrast. Because you're going to ask this question a lot for the rest of this unit. How do I know what to do next? Okay? And I'm helping you out with this one term versus many terms things just to start off. Here we go. I'm going to use the limit law. Is this allowed?
Yes.
Yep. Did I distribute? No. Just apply the integral to all three. Here we go. What do you think I would do next?
Reverse product rule.
Not reverse product rule.
Power rule. Reverse power rule for the first.
I would do something I would do something before the reverse power rule. And I'm giving 100 points because this is a big thing that a lot of people overlook. But it will help you with the more difficult things that are coming your way soon. Chloe said take out the constant and use constant multiple rule. And this one would be taken out. Alright, so I apologize that that kind of empty space is in the middle. Let me kind of make this easier for you to read.
Wouldn't that just, is it just 4 though? Like, is that what that equates to?
We'll get to it in just a bit. Okay? Here we go. The reverse power rule, where we add 1 to the power first, and then divide by the new power. So this will become x to the third over the new power of 3. This thing is constant multiple ruled back in. And if I simplify it, it's just x cubed. How could I check it? Well, derive it. If I derive this, would I get back to the original integram piece?
Yes.
Yeah. Okay. So now we're going to go to this x right here. It will become x to the power of 2 over times the constant multiple rule of 5. So this is just that. What would this become?
X.
X. Remember, t was dt, y was dy, z was dz. What am I saying right there? What's the term for those things? The differentials. The small little differentials that exist per the variables that they have. Okay? So, if you don't want to look at it like that, what number is understood to be in front of that dx? 1. What's the antiderivative of 1? X. So this would be plus 4x plus c. Is this that I just boxed displacement? It's not area. It's not displacement. It's not total distance traveled. You forgot already. Area and displacement are dealing with
Accumulation change.
an exact number. Where indefinite integrals are dealing with a function. Was I correct to put f of x?
Do we know? It doesn't say whether or not.
We don't know yet. We don't know yet. I'll tell you right now, a little bit early. The default is this is to be interpreted as this unless otherwise specified. Okay? So when I take the antiderivative, it is f of x. But in the context of this problem, we don't need to write that out right now. That's coming here at the end of class today. Now that I've shown you the basics, we're going to speed things up. Okay, here we go. X to the 5th will become what? X to the 6 over 6 plus c. This is exactly how I want you to write it on your paper, okay? Include the integral. What disappeared? The dx and the summation symbol. What appeared? The c. Okay. This is important because definite integral is about to happen here in just a bit, so you have to know the difference. All right, here we go. What do you suggest I do with 1 over x cubed?
Make it
X to the negative third. What is it that I will then write along with it?
x to the, oh,
Right now, this is wrong.
Like the integral of x to the negative third dx.
Perfect. Have you integrated? No. And you need to show me that you know that you have not integrated yet. Right here, what we did is all about the what? It's all about the rewrite. Because this will make it easier for you. What is x to the negative 3 going to become? X to the negative 2 over negative 2 plus c. Still not right. That's right. There's no negative powers in your answer. A lot is going on right now, okay? Please ask me questions if you have them. What should I do with this one?
change it to x to the power 1/2.
So it's all about the rewrite.
Then add the,
Wait, what?
I was gonna say, add the summation of the x.
Oh, yeah. Ken? Or and then?
X to the 1/2.
Okay, careful. Here we go. When I add 1 to fractions, you need to gravitate to what is that denominator. Because when you add 1, you need to add 2 over 2. So this will become x to the 3 halves,
Over 3/2.
or times what?
2/3.
2/3. Add 1 to the power, divide by the new power. Dividing by a fraction is the same as multiplying by the reciprocal. I think you should do that always with fractions. Okay? Because a lot of things are going to come your way. You're going to see fractions crazy for the rest of this unit. Okay? And a lot of you are going to hate fractions again because of this unit. Alright. Let's go to this one. Without looking. What is the antiderivative of sine? Negative cosine. Because if I derive this, I would get a positive sign. Plus c. Nicely done. What is the integral of secant squared? Tangent.
Plus c.
Is this and that the same?
No.
Nope. This over here on the right is saying that. And you'll learn u substitution the way Chloe was saying with what we just did there soon. Are they now the same?
Yes.
Yeah. Just keep notation in your head, okay? Alright. So now let's move down to... And here's the thing, guys, I'm going to tell you right now. If you worked hard first semester and you did a lot of your homework, this stuff is going to seem easy. And not only is it going to strengthen what you're doing now, it's going to strengthen everything that you used to do as well. But if you didn't do your homework to its full level that you could have in the first unit, it's like you're relearning last semester as you're trying to tackle this thing here. Okay, so keep that in mind. You guys said 1 unit, or 1 term, it'll be easier if we distribute it, right? Here we go. Help me distribute. 2x squared Okay, so let's simplify it. We're-
Plus 5x.
Yep,
Minus 3.
minus 3. Okay? We're going to do this in our head. Constant multiple rule the 2 out. X squared becomes
X equals 3 times 2.
times 2. Constant multiple rule the 5 out.
X squared over 2 times 5.
Right? What does this minus 3 become?
Minus 3x.
And then,
Plus C.
because it's a what? Indefinite integral.
Isn't there supposed to be a parentheses from 2x?
Here?
When we get to
So listen, real quick. There doesn't have to be a parentheses here, but you can put one if you want, just to show, guys, this is all the integrand. But I don't think you should be thinking that there's a parentheses there, because I don't want you thinking that it's the height times the base. There's no multiplication happening there. I want to make sure you understand that intuitively. Okay? Yep.
When we get to the point where there's multiple C's, do we write it as like C prime and then just keep?
So you will get multiple C's in differential equations, Calc 4. You won't get multiple C's per se here.
Oh,
You'll get multiple C's on different levels, but I think of what you were just asking, no, you won't see that until Calc 4, which is differential equations. But it's huge what you just asked, oops, wrong team, because you will have to take the antiderivative of 2 levels sometimes. And they are dealing with 2 C's. Okay? We'll get to that. How many terms do y'all see? 1. How many terms could we make? 3. Because of what? Ooh, that's what I was looking for. So common denominator, right? So common denominator will break this up and make it easier for us with the rewrite. And some of you might skip this step, and that's cool if you do. And you would even go further and you would write it simplified form. What would I write? X cubed minus 5x
plus 7x to
plus 7x to
the negative 2.
the negative 2. I made it easier by making it more terms rather than just 1. And I also rewrote the powers so that I could use my reverse power rule. X cubed becomes x to the 4th over 4. Constant multiple rule of that 5 out. X will become times the 5 or the negative 5. Take the 7 out. X to the negative 2 becomes
Plus C.
and the only thing that's wrong with this, change the negative power. Ooh, I'm too slow for you. So this negative and positive multiply to give you a minus 7 over x. Cool?
When we're showing our work, we can just do that, right? Like, we don't have to break it up to the integral of x cubed and dx minus the integral of 5x.
Oh yeah. I don't want you to break this up into 3 separate integrals. That was just to show you how what's really happening, but how you can do it all in one shot.
And then, do we need to show like that many steps that you showed, or can we skip any of them?
Oh no, that's fine. That's fine. You can skip. Just make sure that you understand. If you get something wrong and you skip steps, that's partial credit. That's thrown away. Okay. All right. So you substitute. Okay. These questions that I just had, we're going to come back to this one at the end of class. Okay. We're going to now go to. That's U substitution. We'll do next class. We're going to do that. No. not use substitution yet. We're going to do the fundamental theorem of calculus. And this is big. Everything is the same so far, except now we have boundaries. We're saying from this number to this number. Okay? So we are looking at this, but with a function. So what kind of answer are we going to get? A number. Are we going to get plus c? No. Okay? Here we go. So the first thing that you should notice is if I take the integral of the function given, it will spit out for me f of x. And the way that I analyze it is I plug in the b to get f of b, and then I plug in the a and subtract f of a. Can someone tell me why? Final minus the initial, aka displacement, aka accumulation of change or change in position. Do y'all hear what that was saying? Accumulation of change, change of position, aka displacement. Can I interpret this as area? Yes. Can I interpret this as accumulation? Yes. Can I interpret this as a function plus c? No, because it's bounded. Yeah.
So f prime of x is the slope of f of x, which is f of b minus f of a over b minus a.
Yep.
So does the thing like the different summation notation take out like the thing that makes it slope and turns it into like the actual area bounded?
Yeah. Okay. We'll look at that in just a bit. Okay. Some of you just glossed over that because you thought he was just rambling, which he was a little bit, but I know he knows what he's talking about. Okay. We'll get to that in just a bit. Just leave it for now. All right. And if you can finish it off when we get to it with everyone, I'll give you those points that you just earned. Okay? All right. X squared plus 3 is my what? Integrand. When I take the integral, I will get x squared is going to change to?
2x or 3x over 3x.
Come on, guys.
Cubed over
X cubed over 3. 3 changes to 3x. This is called in purple my antiderivative. Okay? It is not the integrand. We went from the integrand to get the antiderivative. This is the integrand. It went to the integral, aka antiderivative. But we don't do plus c. We're going to do, oh, thank you. Team Park caught it first. Remember, mistakes that you find, I give you 100 points easily for those mistakes. So x cubed over 3 plus 3x, we're now going to find this displacement between 1 and 2. But which one do we plug in first?
Wait. Why is it 2 on the top and 1 on the bottom?
That's what I'm saying. Because we're doing left to right. But the way we plug it in is we plug in the top one first because it's final position minus the initial position. Okay? So here we go. F of b, you did that back in Algebra 2. You're just plugging in your b value. Oops, let me do that with blue so you're not color blind. Right here. So it's 8/3 plus 6. Now in green, we're going to plug in what? 1. Because we're trying to find f of a. I'll get 1/3 plus 3. These are adding because this was adding. Why is this subtraction always?
Final minus initial.
Final minus the initial. displacement.
Accumulation of change.
She's like, whatever. Blah. So this right here will give me my answer as a numeric answer, not as a function. So guess what we get to do? Hopefully you're not the person who hated fractions and just made everything decimals, because you have to do fractions, okay? There's a lot of fractions still going on. The best thing that I could do is get everything to have a denominator of what? 3. So that's 18. You see what I'm doing? This one is plus 9 over 3. 8 plus 18, 26. What do I do with the 1?
Add it.
Subtract it. Subtract it.
We'll add it to the
We'll
nine.
add it to the nine.
Oh, you could do that too. Okay, 10 and then subtract the 10 from the 26 and get 16 thirds. 16 thirds. And I'm about to show you something big, and if you can get it, this is another 300 pointer.
Do the square.
No. Okay.
And you have the answer in the mixed fraction form.
You could have it in mixed fraction, but let me change that. You could have it in mixed fraction. I won't count it wrong, but please don't do mixed fractions. Do improper fractions. Like this. You know what I mean?
Okay, you could convert it to proper.
Yeah, but why would you convert it to mixed just to convert it back to an
I
improper?
mean, like this here, you're converting like the.
Oh, I see what he's saying. Look. Look at this. This can also be written like this. Believe it or not, I hate the way we say fractions should be written as mixed because it's wrong. It shouldn't be like this. Because this right here says it's 10 thirds if you learned mixed fractions. But this looks like 3 over 3 to me.
Yeah, not like that, but like if you first combine like the 6 and 3, and I know like the 6 and you subtract it.
I don't follow right now what you're
So
doing.
you're saying like if you add the 3 and the 6 together and the 1/3 and
Oh, okay. If you add these and then subtract this to get 7 thirds plus 9,
Yeah.
you could do that too.
Whoa, what?
That's cool stuff. Because addition is a little bit commutative and so is negatives. So you can only do this if you don't have 2 minuses in a row. If you have 2 minuses in a row, in case you don't already know that, don't do that, okay? Okay. Are we good?
Yeah.
Alright, so this was the displacement. This is change in positions. Watch what I'm about to show you guys. This is big. What was my position when x is 2?
18 thirds.
No,
26 thirds.
26 thirds. This is leading to what Christian was saying earlier. Let's see if he can finish it off. My position is 26 thirds at 2. What was my position at 1?
10 thirds.
10 thirds. Bless you. What was the change in position?
18 or 16 thirds.
16 thirds was a change in position. So as a y value, it just went up 16 thirds. Almost like you're in an elevator and you went up 16 thirds floors. You with me? But whatever the graph looks like, the area is also 16 thirds. So position function on the graph, it's changing a y value by 16 thirds, but also the area bounded between x cubed plus 3, look at that, shifted 3 units up, between 1 and 2 is also 16 thirds. Did you get it? Okay. Let's go with, if you didn't, no worries. let's go more practice because you have homework and I want to make sure you're good on homework. It's all about the rewrite. I'm going to take over a little bit. What could I simplify that first fraction to?
X over, or 1, no, x to the 1/2.
X to the 1/2. You go with me? It was x to the 1 over x to the 1/2. When I have the same power or bases, what do I do with their powers? Subtract. Algebra 2 is coming back a lot with a vengeance right now. So x squared will become,
What, you mean x to the 1/2?
or my bad, I don't know why I said x squared. X to the 1/2 will become
X to the 3/2.
x to the 3/2
By 2
times 2/3. X to the negative 1/2 will become
X to the 1/2.
x to the 1/2. No. Times 2 over 1 times this minus 4. And all of this will be evaluated, no plus c, from 1 to 9. That means plug in 9 first, subtract what you would get when you plug in 1. Here we go, guys. I'm plugging in 9 where my variable is at. What should I do to 9 first? Cube it or square root? Square root. Square root of 9 is? 3. Cube that? 27. Divided by 3? 9. Times 2? 18. There's a lot of that. Plug in this 9. Square root of 9 times 2 times 4. All of that is f of a. And we need to subtract f of b. What's b? Or f of b? 2/3 minus 8. Chances are, yeah, we could do it in many different ways. You're seeing it just like last time. Some of you group things differently. We saw how Omar grouped it, right? I mean, there's different stuff. Just be careful. Make sure you know it's equivalent mathematical. To me, I'd probably see 18 minus 24 and write down what? Negative 6. And then I would see minus 2/3 plus 8. That's what I would see. And some of you might make them all have a denominator of 3. Some of you might look at, and probably Omar, he'll look at negative 6 and 8 and say 2. And then he'll say 6 over 3. So that well, my answer would be what? 4/3. Is this 4/3 units squared?
Just units.
It's not even just units because right now we don't know if it's units. Here.
Well,
If
isn't that
it-
area bounded though? Because it's
Here's the thing. If you see these two words, then it will be units squared. But in the problem, if you were given that this was f prime of x, like meters per second, then my answer would be 4/3 what? Meters. Accumulation of change. But when you don't see this context or these words, just write the number all by itself. Because you don't know what it's representing right now. You just know computationally and numbers-wise, you just did the algebra.
how come area bounded would be meters squared then, rather than just meters? Like I
Because
understand
area bounded,
is-
area bounded is interpreting it as a geometry area, whereas displacement, which is also area, it can be negative sometimes. A geometry area can't be negative. That's why it'll always be units squared. But a displacement, aka area, could be negative. That's why we're just going to leave it as 4/3.
What I'm saying is I understand f prime of x, when you take the integral, you get f of x, you go back and stuff, so that's why it goes from meters squared per second to meters per second to meters, right?
Okay? Mm-hmm.
But then area bounded, are we just assuming it's like, I guess f double prime if we're gonna say units squared?
Oh, we'll get to that a little bit more, okay?
Okay.
Because area bounded, I see what you're saying. area bounded is like between two functions you can sometimes have area bounded. Not necessarily just the x-axis. You see what I'm saying? When you have two functions, that area is always positive. But because you can be below the x-axis, you can sometimes have negative area. Look at this. That's a big question that he's asking, and he's way ahead right now. What if I had this function f of x, and what if I had this function g of x? And I wanted to find from A to B the area bounded. That's positive. But if it was find the area between one function, come on, we'll call it f of x, and the x-axis, now that's negative because that's displacement. Okay? So this right here, and again, he's way ahead, I'll give you 50 more points, will always be a positive interpretation.
So with area bounded, there are going to be two functions.
Area bounded, there'll be two functions. And I know some of you are saying, well, there's two functions already. The x-axis is y equals 0. Yes, but no. Okay? All right. So let's go to some unit circle because I got to hurry up. I'm running out of time. Man, y'all are asking great questions. I'm running out of time. Let's go to secant squared x. What's the antiderivative?
Tangent x minus
Tangent. No plus c.
Oh, because it's
It's a definite integral. What's the tangent of pi over 4? 1. What's the tangent of 0? 0. Answer's 1. Let's do this one. This one's big. 2x minus 1 looks like this. Negative 1 with the slope of 2. You with me? And we're going to integrate from 0 to 3. So we want to know this area and this area.
why are there absolute?
You tell me. What is this absolute value talking about?
Is that the function or is that?
I'm trying to listen. That's part of the function given. Yep. It's part of the function.
So then would it not be absolute value shape for the graph?
So it should be an absolute value shape. Absolute value is always going to be what?
Right side.
Positive. So this little smidget right here is actually going to do like a vertical reflection across the x-axis and be here. To where the area that we're actually going to interpret is this. What 3 words have we done that talks about this?
Total distance traveled.
Ooh.
I was thinking it, I just didn't say.
That was a big one. You should have said it. That was 300. So total distance traveled is the interpretation that just happened. And we're going to learn how to do this by hand right now. Okay, here we go. If you see a... Go, hurry.
Sorry. So since it's -1 though, so what I was saying is that since that's the integram and you haven't taken the integral of that yet, that function is not like the actual square or absolute value of 2x minus 1 function.
Yeah, let's wait for it. I see where you're going with it. Just watch real quick, okay? Right now, the graph is correct. Ready? You're not going to have negative areas. Cancel out positives. It's total distance traveled. And the way you're going to do this, and you'll see it on the quiz and also on the test by hand, is that you have to look at this piece in the absolute value and find the zeros that exist. There it is. So this tells me I'm going to have to break this up and add it with the other piece. You with me? What did I not write? What did I no longer write down?
Absolute value.
The absolute value, because I'm accounting for it. Displacement or total distance traveled?
Displacement.
Displacement. How about here?
Displacement.
Displacement. But what am I trying to interpret from all of this? Total distance traveled. So guess what I'm going to do after I get my antiderivative and plug it in? Here we go. 2x becomes x to the 2 over 2 times the constant multiple rule of 2. What does it become? X squared. What does the minus 1 become? Minus x. This is my antiderivative that I'm evaluating from 0 to 1/2. Whatever I get, I'm going to do that afterwards.
Wait, why again?
Because I could possibly get a negative answer right here in black.
You do that?
I can't because it's a displacement interpretation.
But I thought we took care of the absolute value.
But listen,
Displacement.
if I just wrote this with no absolute value, it would continue to come down. And this area is what is here. But as soon as I absolute value it, it becomes up here.
And from 0 to 0.5, if you take the square, if you square that value and then subtract the x, it's going to be a negative number. Because in that little
Yeah.
sliver, it was on the x-axis.
You with me? So over here, we're going to do the same thing. It'll still be x squared minus x, but the difference is we're going to go from 1/2 to 3. And please remember this, guys. Absolute value that piece. This isn't necessary because it's still positive, but you don't know that. Sometimes you won't even know what these graphs look like. You just have to find the zeros, find each independent displacements, absolute value, all those independent displacements, and then add them all up together.
It's like velocity stuff.
Okay? And to finish today's notes, there's another example. I will take you to this. So ultimately, our goal with indefinite integrals is to do something that looks like this. Look at this. Acceleration is the derivative, or a of t, which is what? Ooh, a little hesitation. There's a little hesitation. Because you finally learn how to walk backwards, and I say, all right, let's derive. And you're like, whoa, what just happened? So, 12 t squared, right? Minus 6t plus 0. If I plug in 2, I will get 48 minus 12 is 36. It could be meters per second squared. It could be anything. We're going to write, please don't put up yet, we're almost done, units per time squared. We have 2 minutes, a minute and a half actually. And this is the biggest thing that I wanted to show you. To get to the position function, we have to integrate. T cubed over 4 times 4 becomes t to the 4th minus t cubed plus 5t plus c. This is f of t. If I plug 2 in where the t's belong, what would I plug in for this? I would plug in 3 because it's the position. So I'd have 3 is equal to 16 minus 8 plus 10 plus c. What would c be?
Wait, why would...
Negative 15. You can watch the video later, but I need to finish this up real quick. Please listen. We now went from something that might have looked like this. We were given a point so we could find this and make a general solution into a particular solution. And this is the function that we came from. G of x, Google. Google stock, G of x. Starbucks stock, S of x. We just came up with the original function so that you can predict the future by analyzing the integration of changes. This is how World War II was predicted. This is how 9/11 was predicted. This is some powerful stuff.
Mr. Gomez,
So,
why do